Hello. Another example on how to work these representations. Remember, we're talking about a model where something has a constant velocity, or at least it's close enough to a constant velocity for us to say in this instance or in these examples, close enough to a constant velocity. We're going to model it or analyze it as though it does have a constant velocity. Um, the assignment sheet that we're looking at in general, constant velocity model representations, CVM for constant velocity model. Um, this sheet has a variety of different questions on it. All of the grayed out sections do have useful information, but there are things where you will gather information from them to do the other sections of the problem. But they are not questions that you have to answer. Um, this video is going to look at this constant velocity practice problem. Um, the grayed out sections there, this part has been done. These parts have been addressed on earlier videos. What we're going to take a look at on this video, excuse me, is the data section, the execute the plan section, and the answer section, just how to go through and do those things. So the data section, just trying to gather all the information that we can about the stats or the data for the motion that we're studying. So in this example, we've got the diagram-based representation where we're saying this is 0 is over here, we're going in the positive direction. We have a final time and position, we have an original time and position. Those values right there, I can just put clickety-clack right there. So DO, 300 meters, DF, 700 meters, TO going back here, 0 seconds, TF over here, 4 seconds, and there you go. That's it for those. The V is a question mark in this example problem. We're trying to solve for that for that velocity. Pardon me. Let's see. So for some of the questions that you have, you'll have to gather this information from maybe a diagram-based representation. Maybe you'll have to get it from the graph. Maybe you'll have to go up and get it from the word-based representation. The information will be there. You have to find where it is. Then we've got the plan. Remember, the velocity is the slope of a position time graph. And slope is y2 minus y1 over x2 minus x1, rise over run. We have a position time graph, so df minus do is like y2 minus y1. tf minus to is like x2 minus x1. So I'm going to go over here. I'm going to think about using this equation as my guide, but I have all the numbers that I need here. And so these steps where we kind of go little piece by little piece by little piece, that's kind of lightening the load on what our brain needs to keep track of at a time. So doing those sorts of things really helps us limit our mistakes. So I'm going to punch in our df minus do. So that's 700 meters minus 300 meters. I'm just going to punch those numbers in here. And notice every time I have a number, I also have a unit of measure. I don't just leave it as 700 or 300. I put the M on there for meters. And then, oops, a little bit too far. Come on now. Then below it, I'm going to go with TF minus TO, or 4 seconds, 0 seconds. And then to show this, I'm just going to do Control U to underline it. That kind of looks like a fraction bar. Now this stuff gets kind of time consuming as opposed to pencil paper. So if you want to write these out pencil paper, still showing the required work, but just writing it out pencil paper, perfectly fine. Write it out pencil paper and attach your images to, take a picture and attach those images to these assignments. Perfectly fine. And now we have 700 meters, 300 meters, 4 seconds, 0 seconds. We've got all that. And then over here, we throw those numbers into our handy dandy calculator and we see what we get. I don't know if this shows up when I do this. I have a calculator on the monitor on my screen right now. I would think it would show up for you, but apparently when I do um, Google Meets, it doesn't show up. It's its own separate window, so it might not show up. Hoping it does. So if I say 700 minus 300, there I get 400. Easy enough. This calculator doesn't let me do percentages, or pardon me, parentheses, so I'm just kind of going step by step. So the 700 minus 300, 400. And then I have 400 on top divided by 4 seconds. So if I do that divided by 4, I end up just simply getting 100. So my velocity here is 100 meters per second. That's moving at a clip, boy. So that's how we go through and do these. I want to show you one more thing, just because there are a couple of examples of this. There are a couple of questions where the other portions of this question are provided. So it might be that like the execute the plan and the answer are made available to you in the problem, but the data isn't. So you could, in these cases, just say, well, it's DF minus DO. 700 must be my DF. So I'm going to put the 700 there. DF minus DO, 300 must be my original position. I'm going to put that there. Right. So we can gather that information a variety of ways. There you go. Have a good one.